Okay, so for number 8, it says that we are given the equation 3x minus 2y equals 12. And this one actually looks different than all the other equations we've been given. Normally we get something in the form of y equals mx plus b. This time it's not. It's a number times x plus or minus a number times y equals another number, a constant. So we call this the standard form equation. Okay, and the sucky thing is the standard form equation doesn't give us a slope and a y-intercept. It just gives us the standard form. So we're not going to have the slope and y-intercept like normal. Okay, so I'm going to write down my list of things: graph, equation, intercepts, slope, and 2 pretty points. Okay, so this time I got the equation. It didn't tell me it had to be an slope-intercept form, so I'm just going to write that one down. Okay, I've got an equation, so my first thing is always to graph it. So I'm going to clear out what's in my Desmos, and I'm going to put in my 3x minus 2y equals 12. Okay, now in order to find my slope and stuff, I'm still going to have to follow my old steps. Even though I already have an equation, in order to find slope, I'm going to have to put 2 points in a table. And I'm going to have to type in my cheat code to find that slope. So I am kind of going to do the same steps as normal. So let's find some points. So I'm going to start with the intercepts. And hey, the intercepts are nice. So I'm not going to have to do any different points because the intercepts are nice. So the intercepts this time are 4, 0. I'm going to write it as ordered pairs just so that I can use them as my pretty points too. 0, negative 6. So there's my points. There's my intercept. I said I need to get slope, so I'm going to have to put it into my Desmos. Okay, so my first thing is to put those 2 points in, 4, 0, and 0, negative 6. Okay, and then I'm going to put in my cheat code, y1 tilde mx1 plus b. I like to write Desmos near it, so I know that this is what I did in Desmos. Okay, so I'm going to make a table. Okay, notice that I kept the equation in there just because at the end I want to see if it actually lines up all on there. 0, negative 6, and my cheat code. Okay, notice that the black line is on top of the red line. So if I click on the black equation and then I click on the red equation, the color of my line is going to change. Okay, so I've got my m is 1.5 this time, and my b, I already know it's negative 6 because I did it in the table. Okay, so the m is what I care about. That's my slope. And then I just need to draw the graph. I know my 2 points, so the graph will be nice and easy peasy from here. So there's the x, there's my y. I know that I've got an x-intercept of 4, so 1, 2, 3, 4. And I know I've got a y-intercept of negative 6. 1, 2, 3, 4. Oh, let's make this go down. 5, 6. And I'm going to connect them with a straight edge. Okay, so I'm going to ask us another question off to the side. Okay, I want to know if the point 6, 3 is on the line. So 6, 3, and I'm going to also check the point for 0.1. Okay, so that's sometimes something that they'll ask us. Are those points on the line? So anytime that happens, I always start by making a table. And I put the points inside the table. So 6, 3, 4, 0.1, and then I can look for them. Now, this table, it made it green, and my original table was green, so why don't we just clear out this stuff so that I can easily see it. Okay. So here's the 2 points. So sometimes it helps me to zoom in to see if they actually fall on the line. So if I do that, I can see that this point falls perfectly on the line. So that's on the red line, so that is a point on the graph. But if I look at this one, when I'm zoomed out, it looks like it's on the graph, but when I zoom in, it doesn't look like it's on the graph. So here, it looks like it might be off, and when I zoom all the way in, I can see that it's for sure not on the graph. Okay, so anytime I've got points, I just plug them into a table and I see if they lie on my graph.